So first what I said, the first I have talked about what is parameters, what is statistics, what are the way data are there, how the data arrays have been happen, and frequency distribution have been drawn. I have not gone through that in more detail. The reason was that everyone is the master graduate, so they are knowing about it more. So my more importance is being coming to the fundamental of statistical analysis of data. And this is going to be considered as the very significant point for you. So there is a common sampling techniques which is important for us. So I already said in the previous session number 1, that data may be normally distributed or non-normally distributed. When we take the database of the own state of India, then it is known as non-normal distribution, because on state-wise, the behavior pattern and everything is going to be changed. But when we take a database of a particular state, citizen, then the behavior is generally normally distributed. So statistic associated with a frequency distribution and measurement of the same. That's very important. So measurement of the scale, measurements and that is going to be done by two ways. Number one, skewness. Skewness is basically indicating the tendency of deviation from the mean to be neither in one direction than the another direction, and that is going to be the one of the significant point to happen. See, understand, tendency of the deviations from the mean to be neither in one direction than in another. That is the skewness. While kurtosis is basically the measure of relative pickedness, of flatness of the curve. Sorry, somewhere I could not draw it properly. Now I'm drawing it. See, measure of the relative pickedness or flatness of the curve defined by frequency distribution. The kurtosis of a normal distribution is 0. That what is being said. So skewness is basically the deviation from the mean, where it may be going on the one of the side more. So you can say that your data may be left-trained or the right-trained. Means people are behaving in a particular way or people are not behaving. It can be thought of tendency of a one train, and that we are saying left train and the right train. When kurtosis is giving the measure of the pickedness or the flatness, means up to which higher level or does the data is coming to the flatness level, which means that if we may say the hill of the mountain, or we can say the ground area. Okay, these are the two words I have been used. So when we say the hill of the mountain, then it is going to be relative pickedness. When we say the ground level, it is going to be the flatness. So kurtosis of the normal distribution, where it is going to be the normally band shape, so their kurtosis is going to be 0. If the kurtosis is positive, then distribution is more peaked than a normal distribution. It's very important. If it's a negative value, means flatter than the normal distribution. This particular information is quite important when we do the sample study by way of questionnaire, by way of survey, or by way of the field study. We have to make sure that how we do it. Now, this is basically says the symmetric distribution. So 15.2 is basically says that it is the normally band-shaped curve where mean, median and mode are same. So it is normally distributed curve. But when we try to be looks toward the 15.2 point B, when the mode is more than median, median is more than mean. So it, in other words, when the mean is smallest, mode is highest, median is in between, it is a Neftain skewed distribution. Neftain. When it is on inversion way, it is known as the right-chain distribution. And this point is going to be quite important. So whenever we have decided that my database is whether it is coming under the normal distribution or the abnormal distribution, it means not normally distributed. I use the word abnormal sometimes. Neftain, right-chain. Now in our earlier slide we say 15.2.B, it was a Neftain. So whenever I select my test, then I have to develop my alternative hypothesis in such a way that those alternative hypotheses are being in a proper way. So we have to formulate the hypothesis as none and edge alternate. Okay. Now, HGO and H1 is going to be the proper hypothesis, same bias. Then we select the appropriate test to be used by us. Which is the appropriate test is to be done. Then we choose the level of significance that I explained it in the first session beginning, that whenever we do the medical science study, we may be looking towards the 1% level of significance, which means that the 99% confidence level. When we try to be looked towards the general commercial study, we say it is going to be the 5% level of significance, means 95% confidence level. But you see, I took the second step is select the appropriate test. Because once we decided whether our data is going to be kurtosis based or NAP based, then we choose the particular level of test. Then we connect the data. So see, it's a very important thing. Then we connect the data and calculate the test statistic. So the students who are going to be use the questionnaire and survey based technique, my suggestion is that you should connect the pilot based data study for 10 to 50 samples. Try to find out the conbench alpha value. If the conbench alpha value is going to be greater than 0.7, in those particular case, you can go to the major data connection. Second thing, when the Cronbench alpha is going to be 0.7 or more, and consumer behavior type of thing, or woman entrepreneurship research study is there, then we have to say that which are the psychological parameters are going to be the part of that. So you know what is going to be happen, that there is going to be the optimistic view, then consistency of thought. So from your question, you can go to the factoring level. So factoring is going to be affected by the coordination coefficient. So if your questionnaire may be indicating the 30 question belongs to project, your data is connected for 30, but whenever you are coming down to the data conclusion, then the 20 to 25 may be only the important question and being grouping into certain way, and that is basically known as a component factoring, which is very important, because generally we say something has no meaning. We have to say that it is going to be depends on the persistency level, it is going to be depends on the race, caste, something like that. You can continue it. So you connect the data, then determine the probability associated with test and compare this with the level of significance alpha. You know that is known as the p-value. Probability value is known as the small ethnic p-value. So when the p-value is given by the SPSS or statistical working is less than 0.05, it means that there is a non-hypothesis have been rejected. It means that the alternate hypothesis have been accepted. This is the one way to verify. Second method is that you determine the critical value of test statistics. It means that you calculate the value of a particular test, then compare it with the table value. If the calculated value is greater than the table value, it means that null hypothesis have been rejected. Okay, that's very important. And based on that, you can draw the conclusion. Now, the procedure to be used is a very important now. If you want, you can write down in your diary or notebook also the small points instead of to depends on the systems and that later on. You can study this particular thing from the different type of the research methodology books. Okay, research methodology by C.R. Kothai is considered as a good book. William book is also considered as a good book, and one or two books of copy I am also going to be part with you. A general procedure for hypothesis testing. So it's a very important. See, when you do the PhD, your mind should be clear that what you are going to do it. So you should go to the stepwise. I suggest up to that level because I did in the menu and structure. During those time, such type of today's statistical tools are not being available. Statistical tools, techniques were available, tools were not available. SPSS was not available. Excel sheet was not available. Majority things we have to do it manually, including the calculation of the regression coefficient. So what you can do, you can just make a table and define it like what way it is happening, and parallelly you prepare the bibliography for the same. Because in the literature you have studied like how you can do it. So those are going to be applicable here also. Like you can say that I developed this null hypothesis based on this particular book. Then you can make it. Okay. So you formulate the hypothesis. A null hypothesis is a statement of the status quo, one of no difference or no effect. It means that you can say that the strictness of the punishment does not affect the behavior of the two-wheeler driver. So you can say there is a no defect. So if the null hypothesis is not rejected, no changes will be made. Like you can say that whenever there is a pharmaceutical tablet or some mania tablet of X and Y company is taken. So whether you take the mania tablet of X or Y, there is no differences happen in the result of the treatment. Then it is null hypothesis. We are nowadays government of India saying the generic medicine and ban medicines. Okay, so they are being of the opinion of the null hypothesis that whether the particular patient is using the banned tablet or the generic tablet, no difference is seen. That's a very important part. So it's a null hypothesis. But the alternative hypothesis says that some difference or effect is expected. Like it is said that whenever the banded tablet have been used, then the recovery of patient is faster than the generic drug. Okay, so you can say that banded tablet is faster, means you are taking it on the right day, and that is known as the alternate hypothesis. Alternate hypothesis can be three ways. Number one, I can say generic medicines have the lesser effect than the banded tablet, then it is naphthene. When I say that banded tablet have the higher effect than the generic, then it's a right thing. When I say that there is no change in the treatment of effect, it is non-hypothesis. So I think you got the point clearly? Hello friends? Hello? Everyone got the idea very clearly? Huh. See, this is a very important fundamentally we have to learn it. The null hypothesis refers to a specified value of the population parameters, where the mu, this is known as the mu. Okay. This is being pronounced. This is pronounced as mu. Okay. You can say sa mu. Mu is basically the standard deviation of the population. This is known as the standard deviation of the population, and this is known as the alpha value and not a sample statistic. So sample statistic is using the x bar. Now here I am taking the example. A null hypothesis may be rejected, but it can never be accepted based on single test. And that is why you know that when the government of India or the international medical organizations were trying to be developed the vaccine for the COVID-19, they have done a first test, second test, third test, and after the few tests have been passed on, it is being approved to be given to the society at large. So you understand that they have developed the medicines based on the single test. They have not decided to reject or to accept it. So in classical hypothesis testing, there is no way to determine the null hypothesis system. In marketing research, the null hypothesis is formulated in such a way that its rejection leads to the acceptance of desired conclusion. It means that the marketing person would like to say that consumers are going to be affected by our advertisement, our price structure, the packing we have been using. So, the alternative hypothesis represents the conclusion of evidence which is sought. Now, research corner, who are from marketing, you have to understand that for you the very important thing is to accept or not to accept the alternate hypothesis. When it comes to the finance, accounts, HR side, human resource side, and so we are supposed to go with a null hypothesis. The alternative hypothesis represents the conclusion for which evidence is being sought. So here it was said that a null hypothesis value is going to be lesser than or equal to 40. That is null hypothesis. While H1 says, it means alternate hypothesis says that expected value is going to be 0.40. It means that the price is going to be giving the effect more, like that. The test of the null hypothesis is a one-time test because the alternative hypothesis is directionally. There what we did, in year slide we did it directionally. We said greater than. Here we said greater than. If that is not the case, so here we are saying it is not equal to 40. It means that we are taking it that it may be positively benefited, it may be negatively benefited, and the two tests are to be used by us. So when we say the 5% never of significance and our alternate hypothesis have been developed on the two test base, then we have to refer to the table value of 2.5% because 5% divided by 2 means 2.5% each. Or whenever we take the p value, then we will be taking the value for rejection of the null hypothesis is less than 0.025 because p value is always indicated by way of the decimal point. Number 2, we have to now select the appropriate test. After 10 minutes, I will give the 5 minutes back, okay? Select an appropriate test. The test statistics measures how close the sample has come to the null hypothesis. This is the test statistics we are going to use it. The test statistics often follow a well-known distribution such as normal T or chi-square distribution. Friends, one thing you can keep in mind that formula of the Z test and later on what I am going to be giving of the T test, both are nearly same, only small changes come. Okay. So in our example, the Z statistics which follow the standard normal distribution would be appropriate. So Z is equal to P minus pi upon standard deviation P. So standard deviation by P is equal to pi into 1 minus pi upon n. This is basically known as the probability of happening of something. Then we have to choose the level of significance. Now, we have to understand that whenever we are doing the statistical study and everything, what type of error can be happen? That is known as the standard error of statistics. Whether those standard errors are being happen randomly or is happen on account of sampling. So type error occurs when sample regions needs to rejection of the null hypothesis when it is due. It means that the null hypothesis in practical way it is due, but our sample regions are saying that null hypothesis is rejected. Then it is known as type 1 error. In the type number 2 type of errors, null hypothesis is not rejected when it is in fact false. So it's very important that when the null hypothesis is false and we are not rejecting the null hypothesis, then it is type 2 error. When the null hypothesis is true and we reject the null hypothesis, then it is type 1 error. The probability of type 1 error is denoted by alpha, and that alpha is known as the level of significance. So that is what we say, the 5% level of significance. It means that the 95% of confidence level we have it. And that's going to be the one of the very important thing in the normal cases. That what way the regions are going to be happen in the normal cases. The probability of the type 2 error is known as the beta. Unlike alpha, which is specified by the researcher, the magnitude of the beta depends on the actual value of the population parameters or the proportion. Now we have to decide the power of test. Is the probability of rejection of null hypothesis when it is false and should be rejected. That is 1 minus beta, means 95% confidence level. Although beta is unknown, it is related to alpha. And extremely low value of alpha will result in intolerably high B errors. So in medical also we are not taking the value of alpha less than 0.01, okay? Because 1% we are accepting. That is 6 sigma type of application can be useful in manufacturing side, not in the medical side. So it is necessary to balance the two type of errors. Now here I am showing the figure 15.4, where here it is said alpha is 0.05. Friends, very important point. Here I mentioned alpha is 0.05 and H0 is 0.40. So 5%, it means that 2.5% on this side and 2.5% on this side. So both sides we can take it 2.5 and we can come down to the conclusion that what is to be done by us. So here it is considered as a particular way. So here the 5 is being considered as a 2.5 value put up by us in the systematic way. And the Z value at a 5%, level of significance is 1.645. Critical value of the G where the beta is 0.01. It means that there is a 0.01 is once taken. So this is coming to 0.005 and this side is also coming to 0.005. And Z beta value is coming to the negative value of the same. Now this is known as the shaded area. This is known as the unshaded area. Now here when we say that our data of the sample is covered under these parameters, it means that 96.99% is covered under the one test and the unshaded area is 0.0301. And based on this, our conclusion of the research will be procedure we have been using is to connect the data. The required data are connected and the value of the test statistics are computed. The value of the sample in proportion is 17/30. So we can say the 0.567. And the standard deviations have been given to the extent of 0.567. So that is basically the one of the significant parameters have been happening with respect to the working. Yes, please. Any question? One minute. I'm searching out the one file. So just give me the 2 minutes time for the same. Okay, no problem. So when we try to be say that the proportion is a 17/30, it means that out of the total 30 populations, the 17 proportions have been given to that. So that comes to the 0.567. So the value of the standard deviation P can be determined by S follow. Because we are assuming the 40%, there is a probability that something to be happen. So 60% is not to be happen. So standard deviations of the population is being coming to 0.089 because total value is going to be 1. Now, we say that we already calculated the value of the P 17 upon 30. So 17 upon 30, we came to the point 567. 17 upon 30, we came to the value of 0.567. While our assumed value was 0.40 divided by standard deviation of proportion. So the Z statistics gives the value 1.88, which is now going to be compared with a table value. So we will determine the critical value using the standard Norman table, which is being given in the reference book in the short form given to you, which is I think table number 2. The obtaining a Z value of 1.88 calculated. The shaded area between minus standard deviation and 1.88 is 0.9699. Therefore, the area to the right tail is going to be 1 minus 0.9699. So it is 0.0301, which is less than So alternatively, the critical value of Z, which when given area to the right hand side is 0.05, is between 1.64 and 1.65, equals 1.645. That is what we standardized. In determining the critical value of the test statistics, the area to the right of the critical value is alpha or alpha 2. It depends that whether you are taking a one-time test or a right-time test. Hence, I am telling you one very important thing. Whatever way you are going to be use the SPSS, SPSS give you the calculation, but don't try to give the right click to the particular value and give the solution based on that. Reason is that whatever the SPSS program is evaluating may not be correct in each and every case. So it needs to be used by you by your proper own level of subjective thinking. A general procedure of hypothesis testing. Step number 6 and 7 I am comparing. If the probability associated with the calculated or observed value of test statistics, so t-scan, is less than the level of high significance alpha, maybe 0.05, maybe 0.025. I'm repeating, it depends on your research subject or the point you are trying to analyze. The null hypothesis is rejected. The probability associated with the calculated or observed value of the test statistic is 0.0301. This is the probability of getting the p-value of 0.567 when favorable probability is 0.4. This is less than the level of significance 0.05. Hence, the null hypothesis is rejected. I think it's clear to everyone. Null hypothesis is rejected because the calculated p-value is 0.0301, which is less than 0.05. Alternatively, if the calculated value of the test statistic is greater than the critical value of the test statistic, that is the table value, the null hypothesis is being rejected. The calculated value of test statistic is 1.88, nice in the ejection year, beyond the value of 1.645. Because we say that when we are trying to be calculate the Z value at a 5%, the value to be considered is 1.645. So here the calculated value is higher, which means that the null hypothesis is being rejected. Again, the same conclusion to reject the null hypothesis. Note that the two ways of the testing the null hypothesis are equivalent, but mathematically opposite in the direction. This is the point you have to take the care very well. Because if you are doing your doctorate under the very junior people or something, then there is a possibility that you may come to the error of the same. If the conclusion is by hypothesis testing must be expressed in terms of marketing research problem. In our example, we can conclude that there is evidence that proportion of internet users who shop via the internet is specifically greater than 0.40. Hence, the recommendation to the introduced to start the new shopping center. Attendance there. Broad classification, I already discussed the test of association where we are establishing the relationship by the coordination, covariance, and regression analysis. It's a very important test of association to deciding about the factoring whenever the psychological factors are coming into picture. Like for the marketing student, the buyer's psychological behavior may be number one related to the product, which include the product look, price, performance. Second is going to be the brand. Then within the brand also some different parameters may be coming. So that some parameters they are going to be combined together based on the factoring theorem. And factors are going to be set there. So for example, we have the 30 questions are there. Then 6 to 7 questions are going to be combined together under the one classification. Then by thoroughly study about it, we can give the name, higher purpose name of a particular classification. And that's basically known as the theory development, which is our main one. Cross definition we already discussed. Point 3, gender and internet usage we also see. Without and with and without college degree, and they have the expensive automobiles, what we have discussed in the earlier session. Then we have taken the desire to travel also based on the age. Nation 45, more men members having interested to go abroad, when it is niche in case of the female. So now when such type of the case is coming, we have to think over that why. So you can add the third parameters, that family responsibility or like something. Social responsibility, family responsibility. Men will say that I don't have major children education responsibility at this moment, so I can travel abroad before the age of 45. Female says that I will go after 45 because I have to take the care of the family structure. So this is a contradictory points are coming. So this is going to be support you to frame the policy of the organization. And three variables, cross tabulations, feminicide, and eating out, having different perceptions on together. So that is what we are done. by the table number 15.10 at that moment. Now, fast food we have taken. So degree of freedom, we are saying here that COVID-19 happen or not, it may be considered as a dependent variable, independent variable also. And the vaccine taken or not is also being considered as a dependent or independent variable. Someone may try to do the study that the person who have taken the vaccine means independent variable, COVID not happen. Someone say that COVID happened, so people have taken the vaccine. Both way you can study the behavior. So there is a degree of freedom is I minus 1, that is rho number of rho minus 1 and quantum minus 1. So here it is coming 1 multiplied by 1. This is I am explaining the logic how why we are taking degree of freedom. Degree of freedom is basically one of the very important statistical value to know the impact of the overall observations. The null hypothesis of no association between two variables will be rejected when the calculated value of test statistic is greater than the critical value of the chi-square distribution with the appropriate degree of freedom. Same logic is coming here. When the calculated value is higher than the table value, then you reject the null hypothesis. Okay. To determine whether systematic as okay, this I already chi-square distribution, figure 15.8, rejection we are being showing on the right hand side, and it indicates that how the things are going to be happen. So there is no problem is being happening on the same in the normal cases. So now we can say very categorically that rejection is chi-square is basically written like a ethanic x square. Okay, that is a very important point. You have to keep it in mind. The chi-square is used to test whether the statistical significance of the observed association in a cross tabulation. The expected frequency for each set will be calculated by using the simple formula. So we are going to be take the total number in the rows multiplied by total number in the column. It means that the number of observations covered under the each and every parameters we are taking it. For the data in the table number 15.3, you open the data table number 15.3 where the gender and the internet usage data have been given, where we know that internet usage night, so your total is 15, column total is also 15, divide by total value, that is 15 plus 50. That is a night use and high use, or you can say the male user and female user. Both is coming 30. Always it is going to be same. So that is known as 7.5. The same way it is being done for on 4 calculations, that 15 into 15 upon 30. So every place we are coming down to the 7.5. Now we have to calculate the chi-square value, where we are going to be take the sigma of frequency of observed minus frequency expected square upon FE. That is the frequency expected we are taking it. So here it is said that for the data in table number this 15.3, we have seen that the 5 men, 10 female, 10 men, 5 women, and that is the our expected value. Sorry, that is our observed value. Minus 7.5 is our expected value. So we are going to be take the calculation of the .833, like 5 minus 7.5, it means that 2.5 square. So when we say the 2.5 square means 6.25. 6.25 divided by 7.25. So that comes to 0.8633. And that is the valuation we are going to be doing for every calculation. And that's going to be give us the value that 0.83, 0.83, 0.83, 0.833. It means the answer is chi-square value is coming to 3.33. Now the table number 3 in the statistic appendix is going to be give the chi-square distribution value, where you have to refer to the 1 degree of freedom and with a probability of 5%. That is given of significance is 5% for 1 degree of freedom. The chi-square distribution is a skewed distribution whose shape depends on number of degrees of freedom. As the number of degrees of freedom increase, the chi-square distribution become more and more symmetrical. Table 3 in statistical appendix contains upper 10 area of the chi-square distribution. And for the 1 degree of freedom, the probability of exceeding a chi-square value of 3.841. When our calculated value is 3.333, it means that the null hypothesis is going to be accepted. So for the cross tabulation given in 15.3, there are 1 degree of freedom. The calculated value is 3.333. Since this is less than the critical, the null hypothesis of no association cannot be rejected. Indicate that the association is not significant. It means that there is no significant relationship between the male-female and high and no internet usage. So null hypotheses have been accepted. If the calculated value would have been more, then we would have said that it is being higher. Okay. Next is coming to the chi-square value to be calculated from the perception of pi coefficient. Nowadays, people are using more and more pi coefficient because pi coefficient is going to be made the significant too. The pi coefficient is used as a measure of the strength of association in special case of a table of 2 rows and 2 columns. Like you want to establish the strength of association between the gender and the net usage, you can go to the pi square also. That is the one way. So pi coefficient is a proportion to the square root of the chi-square statistic. So pi coefficient is equal to under root chi-square upon n. it takes the value of 0 when there is no association, which indicates that, which would be indicated by a chi value of 0 as when the variables are perfectly associated. Pi square assume the value 1, and on observations may be followed within the more and same diagonal. So here friends, you can see that cross tabulation is being done. Pi square coefficient is specific to a 2 by 2 table. The contingency coefficient can be used to assess the strength of table. We are saying that there is a association is there. There is a association have been established by the pi square. Now we have to decide that what is the strength of that association, and that strength of association is going to be support us to develop the any model or any judgment we have to take. Then this cross tabulation is going to be useful. So we can say it is chi square plus n. The contingency coefficient also g between 0 to 1. Maximum value depends on the size of the table. For this reason, it will be used only to compare table of the same size. It means that if I am taking a table, then if I am making a comparison between the two pair, both should be the same size. Means 2 row and 2 column, then it is better. Or 3 row and 3 column. Another one is coming, Camus V is a modified pi coordination coefficient, and Camus V is to be used when the table is larger than 3 by 3. In a research study, in a research paper publication, you have to be very sure that if my table is coming by the 2 row and 2 column, then I can use the chi square in case of the quantitative data and in case of the quantitative data also. Mainly the chi square in the beginning used for quantitative data, nowadays being used for the quantitative data also. But whenever your contingency table is more than 2 by 2, then we have to use the Camus V table. Where it takes the V is equal to pi 5 coefficient square, and you know that the 5 is equal to x square divided by n. You know this is the same formula, and the minimum of I minus 1 and comma c minus 1 means whatever the minimum value of the value is coming after deducting the word should be used for the Camus V. Then we have the very important calculation is coming, is a asymmetrical lambda coefficient. Hence, I am giving you the formula and the logic behind it. More calculations are going to be done by the SPSS. It's a very easy, and the SPSS 27 version is already in the market. Okay. So you have to be very careful that which SPSS version you are using, MATLAB version you are being using also. But before any statistical study or the decision is taken, you should categorically work out. You should categorically know that what is the situation having happened. A symmetric lambda measures the percentage improvement in predicting the value of dependent variable given the value of independent variable. This is very important for the marketing person, for the HI, training and development and so. We can say that the dependent way, so the independent variable that the price have been changed. How much percentage of the cent can be changed? So asymmetrical lambda coefficient is that, and the lambda also varies between 0 and 1. 0 indicates that there is no improvement should be happen in the prediction. A value of 1 indicates that the prediction can be made by us without error. This happens when each independent variable category is associated with a single category of dependent variable, like a training and development, and so you can decide the impact on the human behavior. Asymmetrical lambda is calculated for each of the variable. It means that in a marketing side, you can take the change in price, then change in the budget, advertising budget, change in the commission percentage, and its effect can be seen by you. A symmetrical lambda also being computed, which is a kind of average of the two asymmetric values. The symmetric lambda does not make an assumption about which variable is dependent. It measures the overall improvement when prediction is done in the both direction. It means that in the case of the symmetrical study, we are not going to be considered the dependent and independent variable. Then another one is coming, tau B, tau C, and gamma. For cross tabulations only, to measure the association. But very important thing, keep it in your mind, write down letter very categorically. Tau B, tau C, and gamma can be used by you when your data is in the ordinal scale. It means that when there is a variables are being given the ranking. So that's going to be very important. Like in some of the questionnaire, we may say that you rank the parameters like 1 to 7 independently, not like in the Linker scale. But you say that there are the 7 factors are there, which may be the more important for you. Like office environment, pay scale, behavior of the boss, behavior of the colleagues, distance of office from the house, which is more important. So you give the ranking according to that. Then in that case, to measure the parameters or to decide that whether our organization should appoint people from which category. So whoever will give the first rank that near to the house, then you should try to appoint the person who is being from the nearby place instead of to taking from the known place. So that is known as ordinal scale. Both tau B and tau C adjust for ties. Tau B is the most appropriate with square table in which the number of rows and number of columns are same. For a rectangular column, where the number of rows are different than the number of columns, then tau C to be used. It means that if your table is by 2 by 3 or 4 by 5, or you can say 4 by 3, then you have to use the tau C. Gamma does not make an adjustment for ties or table size. So gamma is basically when you vary between +1 and -1 and has a higher numerical value than tab B and tab C. Now we come to the cross tabulations in practice. How we can do it? While conducting a cross-tabulation analysis in practice, it is useful to proceed along the following tests. Very importantly, number one, test the null hypothesis. Cross-tabulation, null hypothesis is always to be taken into consideration. Using the chi-square study, if you fail to reject the null hypothesis, then there is no relationship. It means that null hypothesis is accepted. If HO is rejected, null hypothesis is rejected, then determine the strength of association using an appropriate statistics. Normally I say that if we conduct the chi-square and the null hypothesis is rejected, then I normally suggest to calculate everything, study everything, and finally give your answer. Because you are capable enough to establish and understand the pattern of relationship. Now, when you understand the pattern of relationship, gamma is going to be useful. Parallelly, to understand the pattern of relationship, this database, you can learn the coordination and you get the direction accepted or not accepted or contradictory, whatever happened. If the variables are treated as ordinal rather than nominal, then tau b, tau c or gamma as the test technique. If HO is rejected, then determine the strength of association using the magnitude. Because whenever we are going to be use the gamma and so, our answer is coming between -1 to +1. So as we understand that as we approach to the near to the plus point A, it means that there is a strong coordination is being happening. Hypothesis testing tests related to differences. Now, whenever we are trying to come down to the differences between the two, we have the parametric test and non-parametric test. The variables of regions are measured on at least one of the interval scan. In the case of SPSS, interval scan and ratio scan both are same. In the case of SPSS version, they have given the three type of the unit of scale: nominal, ordinal, and interval. So that the interval includes the ratio also. Non-parametric tests assume that variables measured, nominal and ordinal, these tests can be classified based on whether one or two or more variables are involved. The sample size, if independent, see, this is one of the very important thing. The number of times the research scholars are coming to the point that does we consider these samples are independent or dependent. So I put a very specific point in this, that the samples are if independent if they are drawn randomly from different population. Means one sample have been taken from the Bombay city, one sample have been taken from the Pune city. Then they are independent. For the purpose of analysis, data pertaining to different group of respondents are considered as independent variable. Normally, we used to say that the independent sample means city. That is what example I gave by way of example. But in practical, but for this study, we have to keep it in mind that whenever there is a gender studies are being done separately, like a man and female gender study is being done with respect to specific perception, then both samples are being considered as the independent samples. The samples are paired when the data for the two samples unit to the same class. It's a very important. That data is unit to the data is unit to the same group of respondents. Then we consider them as the paired responsibility. Now, this is one of the very important graph. I already given you the copy before a few minutes ago through the WhatsApp to one of the students, and she will be making pass on to others. A classification of hypothesis testing procedure for examining the difference. 15.9 figure parametric test, which is also known in some of the book as a metric test, or non-parametric test is known as the non-metric test. Parametric test means the normally distributed database. Non-parametric test is not normally distributed. Parametric means band shape, not band shape. When one test is there, we can use one sample, we use the t-test or z-test. In the case of non-parametrics, we are using chi-square, ks, Ransom binomial. That we will do later on one by one. Or whenever there are two or more samples, then we bifurcate into the two categories, whether independent sample and paired sample. If the independent samples are there, then we make a two group t test or the z test. Whenever there is a paired sample are there, we are making a paired t test. In the case of the non-parametric test, chi-square is highly used. Then Mann-Whitney test, median test, and KS is being used. Paired test, paired sample, they use Sine, Winnickson, McNamara, and chi-square. So this is the way we have to define our hypothesis test. Now I come to the parametric test, T test. We have already done the Z test before the lunch break. And at that time I said that the nearly the same name of the conceptual formula have been used by the t-test. So the t statistic assume that variable is normally distributed and mean is known or assumed to be known, and the population variance is estimated from the sample. It means that we will be calculating the sample variance, and we will consider the sample variance is equal to population variance. And we can work out the assumed mean value. Like we can say that average age of Indians is 62 years. So that is known as the assumed mean value of the population. And then sample standard deviation we can take it. Assume that the random variable x is normally distributed. કાચા કેવું પછી લગાવી દઈશું બંધ બંધ જ હતી એ મને પાણી પીને આપી જાય બીજું. Assume that the random variable x is normally distributed with mean an unknown population variable that is estimated by sample variance s square. So t is equal to x by, that is the sample mean, minus assumed population mean, like I said that the average age of the Indian is 62 years, divided by the sample variance multiplied by x square. is a T distributed with a n-1 degree of freedom. The T distribution is similar to the normal distribution in appearance. Both distributions are band-shaped and symmetric. Very important point. That as the number of degrees of freedom increases, the T value approaches the normal distribution theorem. This is one of the very significant point, and that is why we are saying that degree of freedom is normally n-1, and that's why whenever we are making the research proposal or we are preparing the doctoral thesis, we are saying the number of samples should be more. Now, hypothesis testing using the T statistics. I'm just speeding running it. Formulate the null hypothesis. Select the appropriate formula. Select the significance level. Normally 0.05 means 5%. Take on mean. Take one or two sample and compute the mean or standard deviation and calculate the T statistic. This is also very important. Calculate the T statistic, assuming HO is true. This is one of the very important points. Here we are assuming the HO is true. 6. Calculate the degree of freedom and estimate the probability of getting a more extreme value of the statistics. So you calculate the T statistic value. If the probability computed in step 5 is smaller than significance level in step 6, reject HO. That's what normally we used to say, that whenever there is a P value is less than 0.05, we should reject the HO. If the calculated value of a test is greater than the table value of the test, then we reject it. Same logic here. If the probability is larger, do not reject the HO. Alternatively, if the value, that is what I said it, of a table value, and express the conclusion reached by you in terms of the research problem. One sample t-test, you open the sheet given by me and go to the table number 15.2. 15.2, as you know, it is coming to which parameters? Tell me. 15.2, that familiarity rating exceed 4, the Newton 7-point scale. Data in table 15.2. Do you have the table number 15.2? Just check it. I'm searching in my niche too. I think by mistake I have not given the table number 15.2. I think it may be fully estimated value. Suppose we wanted to test the hypothesis that the mean familiarity rating exceed the 4, the Newton value on a 7-point scale. It means that you are using a Nimkus 7-point scale and you are assuming the mean is 4, a significance given is 0.05 is selected, the hypothesis is formulated, HO mu is less than equal to 4, H on alternative hypothesis equals to mu greater than 4. So T is equal to x bar minus mu upon standard deviation x bar square. Now standard deviation x bar square is equal to standard deviation under root n. The standard deviation is taken to the 1.579 upon 29. So that comes to the 0.293. So when we put the value in the t-test table, we get the calculated value is 2.471. The very important thing is that, so the t-test here used for Likert scale also. Normally, students used to be saying that Likert scale, which test I can use? People are normally using the Likert scale and presenting the data in the pie chart and such. I say no, it's not a correct thing, because when we use the pie chart and graphical presentation, it is our master degree of thesis, not a doctorate degree of thesis. For doctorate level of thesis, it should be statistically acceptable. So we can use the t-test. The degree of freedom for the t-testing to test the hypothesis about one mean, I n minus 1. In this case, n minus 1 is equal to 29 minus 1 or 28. From the table 4 in statistic capability, the probability of getting a value is probability of getting a more extreme value than 2.471, which we have calculated, is less than 0.05. Alternatively, the critical t value for 28 degree of freedom and a significance level is 1.75, which is less than the calculated. Hence, the null hypothesis have been rejected because the familiarity level does not exceed 4. But here the familiarity level have been exceeded. So by the both calculation, we are saying that null hypothesis have been rejected. So we can use the Likert scale database also to solve the problem. Note that if the population standard deviation was assumed to be known as 1.5 rather than the estimated from sample, it means that some of the owned literature review, some of the own study, you have found the population standard deviation, or you are making a change of that, because instead of to sample you are assuming something, then that test would be appropriate. So here very important thing is that if you are going to be assume the population variance, that is population standard deviation, use the t-test. If the population standard deviation cannot be assumed, then you can use the z-test. So z is equal to x bar minus mu upon standard deviation upon x. And the standard deviation x bar is equal to 1.5, that is the difference between x bar minus mu upon under root 29. When u is coming to the 2.595. From table 2 in the statistics, the probability of getting a more value is less. Alternatively, the critical value for 110 test and a significance level of 0.05 is 1, which is less than calculated. Therefore, null hypothesis is rejected. Reaching the same conclusion arrived at t-table. So, there are to say that there are a number of times the t-test and the z-test values have been calculated. See, the very important point is that, friends, by going through the SPSS and the action command I am giving here, because SPSS is being specifically covered by the Nita madam on last Saturday or Sunday. So I have tried to be cover up some formulations of the action. So now we will be, you can study further and you can get it. The procedure for testing a null hypothesis with respect to a proportion which was invested earlier in this, we introduce hypothesis testing. Two independent sample means two independent samples we have taken, man and female. People are staying in Mumbai, people are staying in Pune, like that. The hypothesis has taken the following step. Non-hypothesis says that mu1 equals to mu2. It means that the average of the independent sample 1 equal to the mean of independent sample 2. Alternate hypothesis says that it is not same, is not equal to. The two populations are sampled and the means and the variance are being calculated. That is a normal descriptive statistics. You can calculate the same by N1 and N2. If both populations are found to have the same variance, a pooled variance is estimated to compute the two sample variance. So here it was said that S square is equal to N1 minus 1 bracket over S1 square, means the variance of population 1, plus N2 minus 1 multiplied by variance of the sample number 2 divided by N1 plus N2 minus 2. It is being done minus 2 because whenever there is any statistical test is being done, 1 is considered as a one of the place, one of the sample study is considered as the base. So whenever there is a two samples are there, we need the 2 AG. So we minus by 2. And then the sample statistic t-test can be used by applying the formula. Then another test is coming for two independent sample test is the F test. The F test is basically based on the variances. Sample variances are being considered in the case of F test. In this case, the hypothesis, null hypothesis says that variance of the first independent sample equal to variance of the second independent sample. As you know that variance is equal to standard deviation square. Alternate hypothesis says that both variants are not same. The F test have been calculated from the sample variance as follows: Fn1 minus n2 and so. This is basically being done by the SPSS calculate the value of the F test by the ANOVA analysis. The F statistics have been calculated. So using the table point 15.1, suppose we wanted to determine whether internet usage was different for men as compared to female. Two independent sample t-test was conducted and the result was presented in the 15.4. This table I have already given to you. Okay, you have this soft copy being available. You should just see it. Men are female, 15. Females are 15. The summary statistics say mean is 9.33, female is 3.87, standard deviation is also being given. So the F value is coming to 15.507 and 210 probability is, it means that 210 probability, it means p value. I think you understand. When we say the 210 probability, means small ethnic p value is triple zero. It means that it is less than 0.05. So null hypothesis being rejected. The F calculated value is 15.507, which in nature seems to be quite a high value. So if we assume the equivariance, this is the benefit that given by the SPSS, that they give the statistics in the both way, by assuming the equivariance and by not assuming the equivariance. So you can run the test, and whichever the test are being giving the similar reason can be presented in the research report, and which is not being coming, you can easily omit it. Few students are just taking the printout of the SPSS reason and putting into thesis is not a correct way, which indicates that you are taking the figure without understanding it. So that should not be done by you. The case involving proportion for two independent samples is also illustrated using table 15.1, which gives the number of men and female who use the internet for shopping. Is the proportion of respondents using the internet for shopping same? Then we can say HO mu1 mu2 same, not, and then we can say Z test, the proportion of respondent using. Now what we are not seeing only the number of respondents, but we are seeing the proportion of the respondent. So Z test is used as an in testing the proportion for one sample. However, in this case, the T statistic is given P1 minus P2 and the Pund standard deviation. In the test statistics, the numerator is the difference between the proportion of two samples, P1 and P2. The denominator is a standard error of the difference in two proportion given by standard error P1 minus P and 1 upon N1 and 1 plus N2, and the P is equal to combined P. That is N1 P1. So combined proportion having calculated. So at alpha N1 of the 0.05, given table 15.1, P1 means proportion 11 upon 15 minus 6 upon 15, so 0.33. So the combined proportion value is coming to N1 into P1 plus N2 into P2 upon N1 plus N2 means 0.567. So the standard deviation is being calculated 0.181. So Z value is coming to 1.84, which is greater than the 1.645. So the null hypothesis being rejected. Given the two tests, the area of the right of the critical value is okay. Here take a 2 up. Hence the critical value is 1.96. Since the calculated value is nice, the null hypothesis cannot be rejected. If I have taken it to the 210 test and the 5%, then it is 1.645. So understand, number of time in a critical research paper, critical study, we use the more and more probability value and the percentage value. And then we come down to the range of the situation. And based on that, certain medicines are being developed, or whenever we say the automobile companies are being deciding the emission system to be used by them, so that pollution in the environment cannot be happen, or average can be maintained in such way. Since the next and critical, the null hypothesis cannot be exacted. Thus, the proportion of users is not significantly different. Not that while the difference is substantial. It is not statistically significant because of small sample size. Understand the proportion of user. When we say 0.733 and 0.4, it means that the main member users are 83% greater. So if you look to the absolute value, it is significant. But as we are having a small sample size, it is not significant. And that is why we are normally saying that calculation of the sample size is quite important. And the small samples are normally not being considered better way. The difference in these cases is examined by the paired sample t-test, paired sample. Okay. To compute the t for paired samples, same sample at different time. To compute the t for paired sample, the paired difference variables, compute given is form and its mean and variance is calculated. Then the t statistic is being applied. So here we can say that mu difference is 0 is not 0. At mu is equal to 0, mu is not equal to 0. So 3n minus 1 means we are taking the paired sample difference variable. Same logic, d is being calculated by taking n sigma di upon n, standard deviation always n minus 1, and then Punch standard deviation, that is SD upon. In the internet usage example, table 15.1, a paired t-test could be used to determine if the respondent differed in their attitude. Yes, male and female, two samples, towards the internet and attitude towards it. And the resulting output is shown in table 15.15. This is also I have given to you. Table 15.15, number of cases 30, mean 5.167, standard deviation and standard error. Difference of the mean, both mean difference is coming to 1.067. The standard deviations is being calculated, that is the combined. Standard error is the combined. Okay. Then we take the 210 coordination, where it was said 0.809. It means that there is a strong coordination exists between the two. T value is 7.0959. Degree of freedom is 29. 210 probability is 0.000. 0.000, which means that the null hypothesis being rejected, and there is a difference is there in the attitude, but those is being coming with a coordination 0.809. So this may be used for factoring proper number of time. Non-parametric tests are used when the independent variables are non-metric. Non-parametric tests are available for testing variables from one sample, two independent samples, or two united samples. This is a very important thing. Non-parametric tests can be used for from one sample, two independent samples, or the two united samples. We can use the non-parametric test. Now, non-parametric test, Kolmogorov, Smirnov is one of the very important. Sometimes the researcher want to test whether the observations for a particular variable could reasonably have come from a particular distribution, such as the normal, uniform, or Poisson distribution. We can use the Kolmogorov-Smirnov KS1 sample test, and this test is basically considered as a goodness of fit test. Very important point is this is known as a goodness of fit test. The KS compares the cumulative distribution function for a variable with a specified distribution. A1 denotes the cumulative relative frequency for each category of theoretical distribution. Cumulative relative frequency. It means that the summation of the frequency is done as we move for each class interval or each type of the group data. So Ks is the based on the maximum value of the absolute difference between the actual value and observed value. But here one thing is that it is basically considered as a omitting of the sign. Yes, friends, now we are being on the very important thing, that is the non-parametric test and one sample. I am repeating the point. Normally we used to be say that large sample means larger than 30. But in the case of the KS test, we used to be say the large sample means more than 35. This is the point you have to keep it in mind. So in the context of in-test use, internet usage examples, suppose we wanted to test whether the distribution of internet usage was normal, a KS1 sample test is conducted, and the data have been shown in table 15.6. It is observing the K value is 0.212 as determined by normalized Z statistic value is 0.0103. Since this is more than the significant level, the null hypothesis cannot be rejected. So we are coming down to the same level of the conclusion. Hence the distribution does not deviate significantly from normal distribution. This type of tests are sometimes required when there is a funding proposal is happen for any of the project, or there is going to be the government of India or the UGC is providing the funding proposal, then there is a comparisons have to be done between the non-parametric and non-parametric test. So here the mean is coming to the 6.6, standard deviation 4.296, cases are 30, 15 men, 15 women. Most extreme difference, absolute is 0.102, 0.20, positive is 0.20, negative is minus 0.142, and KZ test value is coming to 1.217, and the P value is coming to 210, P value is coming to 0.105. So non-parametric one sample, the chi-square test can also be performed on a single variable from one sample. Means we take the simple one variable and we can work out it. In this context, the chi-square serves as a goodness of fit test. The run test is a test of randomness for the dichotomous variable. You are going to be make the run test for dichotomous variable. Dichotomous variable means two variables. The test is conducted by determining whether the order or sequence in which observations are obtained is random. Third test, we can take it of the binomial test. It is known as the goodness of fit test for dichotomous variable only. It tests the goodness of the observed number of observation in each category to the number expected under specified binomial distribution. Non-parametric test. If we come down to the two sample test, difference in the location of two populations is to be compared based on observation from two independent samples, means Mumbai and Pune, and the samples are being taken, and the variables are measured on the ordinal scale, means whether there is a air quantity is important, you yank it like that in the order way. Air quantity is important, or water quantity, or the transportations, or the social behavior, then government attitude, that is local government attitude, and so. Then you can use the Mann-Whitney U test. In the Mann-Whitney test, the two samples are combined and the cases are yanked in order of the increasing size. The test statistic is computed as the number of times a scale score from a sample or group 1 versus the score from the group 2. It means that the difference between the ranking, or we can say that Mann-Whitney U test can be used by the judge of the particular show. Okay, like when we try to be say that it is going to be the show are to be conducted with respect to Miss One competition is going on, and there the two judges are there, and both judges are being giving the ranking on a different way. Then you can make a comparison between the rank given by the judge number 1 to the rank given by the judge number 2, and based on that you can do the Mann-Whitney U test. If the samples are from the same population, the distribution score from the two groups in the rank instead should be random. And extreme U value, the extreme value of U indicates a non-random pattern. And once the non-random pattern is coming, it is indicating that how it is going to be happen in the normal cases. So an extreme value would indicate the non-random and pointing out the inequality of the two groups. For sample is less than 30, See, only KS test is taking 35. Here further he came to the night sample 30 and more. For sample of less than 30, the exact significant level of mu is computed. For larger scale, U is transformed into a normally distributed Z statistics, and that is corrected for a ties between the two parameters specifically. We examine again the difference in the internet usage of men and female. This time, the man Whitney U test is used. One could also use the cross tabulation procedure to conduct the chi-square. In this case, we will have 2 by 2 table. One variable will be used to denote the sample, and we assume the value 1 for sample 1 and 2 for sample 2. And other variable will be binary variable like a 3 and 4 for variable of interest. The two sample median test determine whether the two groups are drawn from population from the same median. Median is basically indicating the on the regions we are being making in our order A, and then we take the median value, that is the median test. And the notation is being used. The conglomerate two sample test examine whether the two distributions are same. It takes into account the difference between two distributions, including the median, dispersion, and skewness. So you know what happened, that in the whole place we are going to the same type of the example, and we try to be on the test result. So in the doctrine test is the same thing to be done. By going to the number of sample study in your data analysis, and you give it, and based on that the tables or the matrix can be formed, and the regions can be presented in the proper way. So man, female, man ang, female ang, F value is given, U W value is being given, Z and the character value. U means man with need test statistics, W means Winnickson test, can also be done by us, and the Z is equal to U transfer. Now Winnickson test, there I have given the region, but here we can say Winnickson matched pair sign. Young test analyze the difference between the paired observations, taking into account the magnitude of the differences. They are going to be take the magnitude of the differences. It compute the differences between the pair of variable and Young the absolute difference. Next step, they sum the positive and negative Young. Z is calculated from the positive and negative Young system. Under the null hypothesis, no difference. Z is a standard normal variate with a mean is 0 and variance is 1 for large sample. It is always being assumed that for the large sample, the variance is going to be the 1. This is normal assumptions we have to do it whenever our statistical answers are not being tallying with each other. Okay. Non-parametric test. We have said that is difference in terms of attitude towards the internet usage is considered. Suppose we assume that both these variables are measured on ordinal rather than interval scale. We use the Winnickson test. So keep it in mind that Winnickson test is only for non-parametric. Other tests can be used for parametric and non-parametric use. The sign test is not as powerful as a Winnickson match pair sign egg test, as it only compares the signs of the differences between the pair of variables without taking into account the eggs. Sign test does not take into consider the egg. But here, Winnickson test is taking the care of the same. Okay. In the special case of a binary variable where the researcher wishes to test the difference in proportion, the Magnet test can be used, or alternatively, chi-square can be used by you. So here the regions are being given of the V. The Z value is minus 4.207. 210 test P value is 0.03. And there is a ties is being happen for the 6 cases. I have given here in this PPT table number 15.19. It is given a sample, one sample proportion distribution means name of scanning. Do you have the metric database or non-metric database, and which test can be used by you? On these conditions have been given in the 3 slides, which can be useful for you. I have given the few sequences of the SPSS window, which you have already studied through the Nita ma'am, but I have just tried to give it from my view, how I do it. So frequencies can be developed by descriptive statistics. So analyze and descriptive, if you go, the major cross tabulation program is cross steps. This programming displays the cross classification table and provide the cent count, row, column percentage, the chi-square for significance, and the on measures has been discussed, whatever been discussed by you. So go to the analyze, descriptive statistics, and cross steps, you can get the better way answer. The major program for conducting the parametric testing SPSS is compare mean. SPSS is basically support you to go to the comparison of the means, okay? And that's going to be the one of the very important thing to you, that how we can compare the different means. So compare means, if you go, you can get the on type of the beta parameters. This program can be used to conduct the t-test of one sample or independent or pair sample. To select this procedure, use the simple technique, compare means, or compare one sample t-test, independent sample t-test, and pair sample t-test. You can also use the non-parametric test, where chi-square, binomial, and everything here is being available. If you go to the SPSS window and if you want to go for the frequency, you go to the analysis, click on the descriptive statistic and select the frequencies. Move the familiar to the variable box, like particular variable, click statistics and select mean, median, mode, standard deviation, variance, and variance. You can continue, you can have the chart, histogram, and everything. Same way you can have the cross tabulations. You can go by the sequence. You can go for the t-test also. I try to be given you a little bit more. Any other question you have before I move to next point? Hence, does it clear to every one of you? Or no? It was clear. It's a very important thing. You have to keep it in your mind.